Alright guys, this video is going to go over any questions you might have had on worksheet number 4. Basically what we would have done in class today is go over worksheet 4, and then you would have had time to work on the review packet for the quiz, and then we have a quiz scheduled for Wednesday. We'll still have the quiz on Wednesday, but remember that there is a Google Hangout available for you to ask any questions before the quiz for tomorrow. And we haven't really done any new material since Friday, so you should be good in terms of material for the quiz. But what I'll do is I'll go over each kind of question, and then we'll move on from there. So why don't we start with number 1 from last night's homework. Remember to determine if you have a function from a list of ordered pairs. You just look at all of these x values here. And if none of the x values repeat, if all of these x values are unique, then yes, it's a function. And the domain is just the set of all the x values that appear. You gotta write them in curly brackets. But besides that, it's pretty straightforward. As for domain, that's just the list of all the y values. 5, 7, 3, and then 5 is a repeat. Nothing wrong with that when the y values repeat. But there's no reason to include that repeat in the range. Alright, when you're doing a problem like number 3 or number 4 where you have a table, it's the same sort of deal. So why don't I just zoom in on number 4, and to decide if you have a function or not, all you have to do is look at the list of x values and make sure they don't repeat. Looks to me like none of those repeat, so yes, it's a function. And your domain, you're just going to list out 5, 6, 11, 19, 22. And then for your range, you're just going to list out all of these y values, and there's no reason to list the repeats in the range. It's just extra work to list the repeats, so no reason to do it. So just kind of a little bit of a review of the concept for tomorrow. The domain is the set of inputs, which also lines up with all the x values, while the range is the set of outputs from your function, and it lines up with the variable y. Okay, so that's page number 1, number 1 and number 4. Let's move on to the next page. Okay, so it gets a little bit tougher when we're talking domain and range from a graph. I can talk about number 5 and number 6, no big deal. So if you're deciding whether your graph represents a function, just see if you draw a bunch of vertical lines, can you ever draw a vertical line that goes through the graph more than once? If you can only draw lines that go through once, yes, it's a function. Now the domain and range is kind of tough for this. Remember, the domain is the list of possible x values that could occur. And so to figure out the list of possible x values that could occur, I like to draw a little stick figure on the x-axis and then imagine him walking to the left and imagine him walking to the right. You want to see how far left he could walk before he reaches the edge of the graph, and how far right he could walk before he reaches the edge of the graph. But because of these little arrows on the end, you could see that this graph is going to continue to get wider and wider and wider forever, negative infinity to infinity. Same thing with the range, actually. A little bit surprising, but when we're talking range, oops, sorry. I'm trying to erase what I drew, but it doesn't seem to want to let me. Okay, in any case, when we're talking range, you have to imagine you've got a little boat, and the water level is falling or rising, and you're trying to get the graph completely out of the water or completely into the water. However, with these little arrowheads, that's never going to happen. So the range for this graph is also negative infinity to infinity. In contrast, number 6, there's going to be no infinities with this one at all, because it looks like we have like an ellipse sort of shape. So that means that there is a furthest left we can walk. We could walk as far left as negative 8, and we can walk as far right as positive 8. Oh, and I wrote infinity, but I meant 8. Infinity looks like an 8 on its side, right? So negative 8 up to positive 8. that. And then for the range, you imagine that you're in a little boat, and you think to yourself, how far would the water level have to fall to get this ellipse out of the water? Well, it looks like -4. Notice I'm putting these in square brackets. And how high would the water level have to rise to get the ellipse completely under the water? +4. And then if you're deciding whether you have a function or not, you draw a vertical line and see if you can make it hit the graph twice. If you can, it's not a function, because for one input, for one x value, we've got 2 outputs, 2 y values. Okay, so that takes a little bit of practice, so you definitely have to practice with that on the homework that you have. But let's do the rest of the material that we've got. So the rest of the material is talking about domain and range for an equation, and that's probably the hardest of the 3 things. Maybe graphs, but I think equations are probably the toughest. Let's do number 18 together. What you have to do with these sorts of problems is first identify what kind of equation it is. And for this one, we can see that we have a square root equation. Basically, if there's a square root symbol in it, it's a square root equation. And the rules for square root equations, the first thing you do to figure out the domain is you take what's underneath the radical and you set it greater than or equal to 0. The reason for doing that, so 9x minus 4 is greater than or equal to 0. The reason that we do that is, remember that the domain is the set of allowable x values that you can plug into the function, and if we want real numbers in this situation, we want to make sure that the thing under the radical is greater than or equal to 0. So I'm going to add 4 to both sides. I get 9x is greater than or equal to 4. I'm going to divide both sides by 9, and I get x is greater than or equal to 4 over 9. Now that will translate into a nice domain. It's the domain that starts at 4 over 9 and continues to get larger from there forever. So the domain from 4/9 to infinity. The range, in contrast, is a little bit quicker. Our range is just from 1 to infinity. Basically, you take the number that's outside of the function, that's outside of the square root symbol, or outside of the square, or outside of the absolute value, and that's going to be your starting point for your range. And then for most of these on this homework, we start at that number, and then we go up to infinity from there. You'll notice that on the next couple pages as well, that we're going to follow a similar pattern for the range. Okay, let's move along. Okay, so on this page we've got a couple of quadratics, we've got a couple of absolute value problems, and then we've got a couple of just linear equations, lines. So let's just tackle these one at a time. Why don't we do one of the quadratics, and then we'll go ahead and move on to absolute value. Maybe let's do 20 and 22. That way we could see 2 examples of quadratics. Here's the nice thing with quadratics, absolute value problems, and linear equations. No matter what, if there's a squared in it, an absolute value in it, or if it's just an equation for a line, the domain is always, always, always going to be negative infinity to infinity. You could plug any x value you want to into y equals x squared plus 17. You could square any number and add 17 to it, and that's fine. So the domain for every quadratic is going to be negative infinity to infinity. So the only time domain is tough is when it's square roots. The range, on the other hand, that's the possible y values that will result. Well, this graph is going to start at y equals 17 and only get larger from there, so 17 up to infinity. If you were to graph this, your graph would look like a parabola that starts at 17 and y equals 17 and only gets taller from there. Okay, why don't we try number 22 and then we can move on. Domain for every quadratic is negative infinity to infinity. And your range, well, you take the k value, the number that's after the squared, in this case plus 0, and your range is going to start there and then go up to infinity. Okay, so there's number 22 taken care of. If you don't see a number outside of the squared portion, then you're going to assume that number is 0. Okay, let's do a couple absolute value problems. Maybe number 25 and number 26. Let's do 25 first. Okay, domain for every absolute value problem is negative infinity to infinity. The range is a little bit tougher, just like with the others. If there's a positive number in front of the absolute value, then you're going to do the same thing we've been doing. Just -3 up to infinity. That's because this is a V shape that's opening up. I can draw a little bit of a picture of it for you. Should help. So we have a V shape, and that V shape is going to be starting at the point -4, -3, 1, 2, 3, 4, 1, 2, 3. The V shape is going to start at -4, -3, and open up from there. You could figure that out by using your graphing calculator to graph this equation. But you could see that the range starts at -3 and only gets larger from there. It starts at -3 and only goes up from there. Okay, let's try number 26 because that one's a little bit tougher because the V shape actually is going to turn out to open down. Okay, so domain, let's get that out of the way. Domain is always negative infinity to infinity for an absolute value equation, also for a quadratic, also for the equation for a line. The range, on the other hand, I'm noticing a negative in front of the absolute values. That means our V is going to open down. That means that our V at its tallest is 9. We have something going on like this, where the V at its tallest is 9 and it goes down from there, meaning that 9 is the largest number on the right, and then it's only smaller from there, so negative infinity on the small end. So these intervals, we're doing the smaller numbers, the more negative to more positive. We're going more negative to more positive. Meaning, since the largest number, the most positive number we can get is 9 for our range, that's going to be on the right side, and then the graph only gets smaller from there, so negative infinity on the left side. It's kind of an important little detail to keep track of. And if you have more questions about this idea, feel free to hop onto the Google Hangout that I set up. Just go onto the Schoology page and ask any questions you might have. You can ask any questions from the quiz review, anything you think might help for tomorrow. And then finally for number 27, that's the equation for a line. It's y equals mx plus b. If you ever see anything in y equals mx plus b form, if you ever see the equation for a line, something like that, the domain is negative infinity to infinity, just like everything else except for square root equations. And the range is also negative infinity to infinity. And that's the video. I hope it was helpful, guys. And do remember that you have a review assignment that's due tomorrow. Same sorts of problems. I'll see you on the Google Hangout if you have any questions. Bye-bye.